Hey everybody, welcome to Tuesday. We've got another Hackster Cafe for you, and I'm very excited to introduce Pierluigi Dalla Rosa, who is an interaction designer who's done a bunch of cool hardware stuff and has a super successful Kickstarter running right now. Hello, Pier. How are you doing?
Very good. Thank you for having me. I'm super excited to be here and having the chance to chat with you.
Yeah. So tell us about this new thing you have right off the bat, because that's your big thing right now.
Yeah. So where to start? I moved to California, I think 7.5 years ago, and coming here, my partner and I, we've been talking about air quality as something that we need to worry about. There is traffic, there are harbors, and a lot of industry around. And then, we got hit by pretty crazy wildfires in 2018, 2020. And so part of that journey brought us to, as makers, we just started to get sensor modules and learn about air quality, both from reading, but also just experiencing how it feels and what are all the sensors that help us to understand it better and to know exactly what it is. And what we learn is that there are all these maps that tells you this is how much air pollution there is in Oakland or San Francisco. But then, what is really, really important about air quality is what happens near to you, what you are actually breathing in your house. And so that's a project that we've been kind of exploring for a few years. We've learned a lot. We learned a lot about the way we cook, what we should do when there is bad air outside, and the way we should ventilate our house, how we should use air purifiers. So all that learning went into a product that I'm super excited to share with folks. Is a very, very simple device. You can see one here is a kind of a dial that has the AQI scale. So the AQI scale is the air quality index, that is a index of air pollution. And the sensor is basically reading the air quality in the space. And then you can see a reading in this kind of dial form with LEDs shining in the back of the wall. So kind of the wall becomes the screen. And so this is in a short form. All there is a very simple product. There is there are a lot of things that we can talk more around it. The values that we put into the product, what we wanted to make with it. But in short, this is the product, and this is what we wanted to put in the world and share with other people.
Yeah, so tell us about your design choices here. You are an interaction designer with tons of experience. How did you decide on this presentation? And I'm going to show a quick zoomed-in version from your Kickstarter, which congrats on hitting your goal a couple of days ago, I think.
Yes, thank you. So yeah, you can see. So these are the interactions are very simple. You tap to see the current reading. And then, if the air quality passes above a certain threshold, that is kind of 15 the AQI scale, there is this kind of glow, red glow that tells you the air, transition to be in a bad state. So you need to do something about it. I think the main choice is, and I think, I can speak to the back maybe of the board. So if you see, this is as a nice presentation in front, but in the back is completely legible. You can read which components are on the board. And we purposefully decided to not create injection molding parts to cover the electronics, but actually to leave the electronics exposed so people can understand what it is. One of the things that my partner and I, we've been discussing a lot, and this is a more ample conversation, more like in the philosophy of things that we can talk about later. But we want to get away from kind of this duality. We want to create a conversation around the products that we create and the products technology that is created, and invite more people to join into that conversation. And part of that is really foster understanding of what the products are. So you can take this board and you can look what is there. There is an SD card where all the data is saved. There is a microcontroller that is kind of the brain of the whole operation. And then we have the sensor that is easily kind of replaceable. So that's another part of it. And of course, there is a environmental conversation too, what it takes to make products. And so we try to make it, to maximize the efficacy of what we can do, minimizing the materials that go into it. So we decided we're going to make it very, very simple. There is no injection molding required. We don't put a casing around it for mostly these two reasons. One is really maximizing, understanding and inspired thinking. So if someone was like, oh, I want to change something, we also put extender headers. So if someone wants to extend the device with, putting another sensor on, or they want to add another way of indicating their quality sensor, they can probably do that. And on the other side, we want to really minimizing the footprint of the things that we build.
I love this. And you mentioned in the Kickstarter itself, all this stuff, I love this, is at the bottom of the project. So there's stuff about the reusable, well, there's the long-lasting design, there's the open source approach, which allows people to tweak it themselves, sustainable distribution, which I love. As someone who's been thinking about doing a hardware company at some point, just like I love, this is exactly the type of stuff I've been looking into. And then also this part where you're like looking at the software side of it, and especially as someone who's done a lot of web interaction design, like someone who's the way that you're thinking about not just throwing those on there just because you can and because it's maybe shiny, but like the fact that that does actually consume carbon, I think is a really cool approach, like doing the local storage and things like that.
Yeah, and so like I put this into the background just now. These are my partner and I, Zaza Zuhoff. She's a designer at Apple. We've been kind of working on these principles that kind of we try to have driving the way we think of technology. I really want to invite more people to have a conversation. I think if we look at the people that build technology, or the conversation on technology, there are the kind of optimists that are, everything is amazing. And then on the other side, we have the people that are kind of pessimists, that like technology is bad. And I think we want to be part of another way of thinking about technology. And we put these principles forward, and this is what we kind of the things that are driving us. So just very briefly, elevate the human condition. The things that we want to convey is, when you put something in the world, think about what it replaces. There is a anthropological, social consequence of technology. Think about that first. Celebrate communal experiences. This is kind of a reflection on computing in general. And minimize impact, strive for longevity. This is another part. When you build things, make them to last a long time, and then cultivate understanding and inspire thinking. These, I think, are the things that we put inside our project. So yeah, and I think I hope I'm glad you are picking them up from the Kickstarter. We try to put them there for people to kind of read about. And I think a big thing that we are not talking enough about, I think, is the software side of things is becoming very opaque. When you do a call on ChatGPT, it's very hard to understand what's the impact of that. But as researchers, as passionate about technology, I'm worried about how much data centers, how much water, how much carbon, how much land needs to go into data centers to do the things that are going, that we need to, that are needed to create that interface. And I think it becomes, very important to think about those. And so that's why one choice we made in this product was to be off the cloud and have a local first approach. And that's something that I've been thinking more and more. Can we enable more devices to be resilient, to work offline? And local first doesn't mean that you are divorced from the internet, but you don't depend on it. And this is a response, to the massive amount of carbon that needs to go into creating kind of the big hypes that we have now, from crypto to AI, but also I think there is response on hardware, right? There is a lot of pieces of hardware that basically are becoming paperweight as soon as the servers are turned off, and that's something we didn't want to see in our product.
Yeah, love it. There's, of course, the iFixit group who are working on making the paperweights happen less. And then also the concept of like the greenest phone is the one already in your pocket and stuff.
Yes.
Yeah. If I may interject really quickly, actually, there's a cool group called climateaction.tech with a subset called Greener Web Dev who are doing some really cool stuff around this. If people are interested in exploring the like more ecologically conscious side of creating technology, very cool. But I love that you're making this front and center of what you do, and it seems like your entire sort of practice and your partner's practice are sort of rooted in this, which is beautiful to see.
Thank you. Yeah, and I love the things that you mentioned. These groups of this new conversation. I think that is going to emerge more and more between independent creators, at least, on how do we make technology greener, better. And I think on the other side, on the design side, there is a group called Climate Designers that I'm part of.
Yes.
That I'm very excited about too.
Let me pull that up real quick. climatedesigners.org. Here we go. Yeah. Good stuff. I've been to, I think, one of their things like long ago, and it's a really cool group of people. So digging back into the product that you've made, tell us a little bit about air quality and why you focused on this in particular. You said you moved to California and there's the wildfires and all, even just like living in cities and stuff, but maybe a little bit more about that.
Absolutely. I think, one thing that I believe is, that technology needs to be, the environment needs to be dressed with technology rather than technology be attached to us. And I think the factors that tells us about the health of the environment are, the water we drink, the air that we breathe. Those are kind of the fundamental elements that are keeping us alive, and having an understanding of them is very important. And air pollution, I feel like, is a thing that we give for granted, or air quality is a thing that we give for granted that we haven't explored enough. But I think in a changing climate as we have, and there are a lot of things that are causing air pollution, and I think especially actually in the US we have wildfires that are a big symptom. It's like a big thing, but sometimes this makes the headlines, and so many other times it doesn't. In the winter, a lot of people burn wood. The wood fires, the domestic wood fires, are actually a big source of air pollution, and the dry season makes also air pollution much worse. And I think having an understanding of that help us to be healthier in general. The symptoms or the diseases that are linked to air pollution there are many. There are, of course, respiratory, from the asthmas to a long exposure. There are potential problems with like lungs and all the respiratory system. But the particles that we are sensing specifically are particles that are very, very tiny. And so what we call particulate matter is this suspension in the air of particles that are very tiny, that go beyond the protections that our body, our nose, our lungs are already putting in place to stop external particles to be going into our system. And so what we are sensing are these particles that are very tiny. They're like 2.5 microns or 1 micron. And potentially when they go inside our blood vessels, they can create cardiovascular problems. They can create strokes. They can create reproductive problems. And I think the fertility conversation is something that is also emerging more and more, and is linked to many different causes. But the particles, what is coming from air pollution, is definitely a big contributor. And I think during COVID also there was a pretty good understanding and statistics about how the polluted cities were actually much worse at COVID transmission. So I think about 15% of all the COVID transmission was linked to air pollution. So air pollution is a very complex problem. It's very multifaceted. It depends on many different things. and not just particle suspensions in the air of particulate. There are many other factors. But we wanted to kind of understanding all of those, and I think the one that is the most urgent to understand is this kind of just like understanding how much particulate matter there is in the air, how much is going into your lungs, and is a very localized problem. It can depend on macro events like a wildfire, but sometimes can be hyper localized. There is the shop next door and that has a lot of cars idling. That you can see it straight away in your sensor when you have a sensor in your home. The way you cook, I think we changed the way we cooked because that's also create pollution that it's hard to identify in the specific. And,
there was a recent huge conversation about gas cooktops and also
correct,
like the carbon monoxide they put off inside your home, but as well as the more general environmental concerns. Very interesting.
Absolutely. So that's all of that is a much bigger conversation, and this is our our response to that. And we wanted to share a project that has been living in our home as a kind of an exploration, as a prototype. But then in the last few months, we were like, what if we share this with many more people? We need to spread the voice, so that's basically what we ended up doing.
And you did create a web interface, so it doesn't upload data to a cloud, but it is accessible over a Wi-Fi network. And you've got this cool web interface where people can get that more granular data. On the front, you have this sort of beautiful hardware design that's very sort of evocative and designy and pretty to look at, and conveys data. But then you also have a much more sort of intense view for people like us who, a lot of the people who watch our channel, people publishing their own projects really want to dig into the data. So you can check this out, find its local web server. And is this something that you can set up in the Arduino software? This seems a little complex for an Arduino HTML page, but
So let me talk a little bit about that. I'm actually pretty happy on how this turned out, and if it's okay, I'm gonna actually give you a demo. This also gives you a sense of the latency. But so what is happening is that the device itself turns into a web server. Right. That is something that Arduino can manage. Is of course limited, so the web page is very simple. But the page is basically gonna read the data that has been saved on the SD card, and it also shares the kind of current value, the current reading. And I'm pretty proud of how we architected this. So the architecture is that the ESP32 acts as a web server and streams just the HTML and a little bit of JavaScript, and then it converts into being a WebSocket server in which it sends all the data. And the template that you see here is actually stored on the SD card. It doesn't live, it's not hard-coded in the Arduino. And this is also kind of the conversation we were having before. We really want to inspire tinkering. If you want to change how this look, the only thing you need to do is take the SD card, put it in your computer, and you can change the HTML, you can change the JavaScript, you can change whatever you want. And basically, there is a sort of library that connects with your quality sensor, gets the data, and then you can change. If you want to have a 3JS visualization, if you want to have something else, you can easily convert this page to fit. You want to make a dashboard. And so really what is as a library, you're going to have this object that is the quality sensor that talks with the sensor, gets the data, and then the HTML page is basically a file that gets served from the Arduino side of things. So we are pretty happy on how this turned out in the architecture. I've been thinking a lot about this. Is I really believe that you get patterns by looking at your data over time. That's something that has served me. This was at first a data visualization project. How do you understand data over time? And you can see the patterns as like, oh, this happens every day, every morning at this time. Why is that? And then you can dig into, and I think to have that understanding, you need to have an interface that goes on over time. And I think the other thing that also this speaks about is the fact that the data is transparent on this SD card. Is the only place where it lives. So you can take the SD card out, put it on your computer. If you want to do a more complex data visualization project, you can totally do that.
Cool. This is gorgeous. I just have to say, there's the image on your Kickstarter, but it doesn't show the cool little animation on there, and I love that.
Oh yeah, and that actually, depending on how bad the air quality, also changes. So if there is very polluted, there are a lot of particles in the background.
Cool. So you mentioned little surprises, like for example, or like things that you might not expect. Like there's a shop next door and they have cars idling all the time. I've been carrying around an AirNet 4 CO2 monitor for a while, and one huge surprise for me was that, like, we talk about airplanes and like the air quality inside of there, but like when I look at the graph, the biggest part is if I take a car to the airport, like a Lyft or whatever, like that actually spikes way up, and that shocked me. Like I wasn't expecting that to be more intense than the airport. So what kind of surprises, if any, have you come across with using this in your home?
I mean, many surprises. I think the first one was, we were, the conversation when there are wildfires, everyone tells you, oh, when the air is bad, go inside. And I think that comes with the understanding that our living spaces are completely sealed off from the outside. And the reality is very different. When we started to measure air quality during wildfires, the air quality inside and outside has a very small difference. But we were also kind of skeptical of how much an air purifier would help. And by the combination of sensing and using air purifiers, we actually had a very good understanding of how much time it would take for the bad air quality to seep into our house, and so how much we would run the air purifiers. So that kind of became something that became natural at some point, but was very kind of a learning at the beginning. Also, we looked at HEPA filters and how they work, and we discovered that they are like actually very good. You can find an HEPA filter and put it in your car, also in basically every car, and that helps you to reduce air pollution in a car itself. We are not big drivers, we bike everywhere, but the few times we drive, you are in traffic, and that's probably one of the biggest source of pollution day to day, and so to be kind of protecting yourself from that. As the thing that is hard to understand about air quality is that it doesn't create anything on the immediate term, but on the long term exposure is what eventually is going to create problems, and it's linked to so many diseases that we consider senile problems, and it really, the cause is this like long exposure to a lot of different things, and air pollution is one of them. And I think also like cooking the way we cook, from certain using the extractor fan helps a lot, and you see it in the data. So I think those two things are definitely something that it's been a learning experience for us.
And how long have you been running this? You mentioned like it was a few months ago that you decided to try and offer it as a broader product. And how long have you been running it before then, as a prototype or as a finished thing?
I think it started in 2017.
Oh, wow.
But so it's been a long time coming. On my website, you can see one of the first. Actually, I'm gonna maybe just share.
Well, feel free to screen share.
There is a kind of an earlier project that we ended up doing in that is in art and is Iris.
It's like, this one?
Yeah. So basically, this was like this is one of our first prototypes that had a lot of problems, but it was kind of a very different device. That, of course, if we grow with it. This is a cute object. We just went for full cuteness. but inside uses an air quality sensor, and basically everything is mediated through this application on your phone. I mean, there were many problems with this, but this is a prototype that we did in response to the 2018 wildfires. And this is how we monitored wildfires at that time. And of course, this is a completely different project. There is basically nothing on this device. Everything happens in the digital space, and we kind of wanted to get away from, like, we learned a lot by doing this project. We didn't want to have relying on a server that, in this case, there was a server in between you and the application, you and your data. And and as the video here is basically narrating, it's like everyone tells you to go inside, but then what's the difference? How can we know really what we are breathing? Here you see a little bit of the making of. This is like, we just 3D printed this little shell. This is the microcontroller. There is an ESP 2866, and you see like the basically sensor modules slot into it, and this is the interface on the phone.
Wow. You mentioned that you went... go on.
Yeah, this is how we started one of the first prototypes, and it evolved a lot on the way.
So you mentioned going full Qt on the design for this one. That is a huge interest of mine, is like, how do we, especially with like robots and stuff, and how they're used and how that can be used maliciously to get through our like psychological defenses. But this is obviously a very positive project, and I'm curious, like, to you, what is going full Qtness? What does that mean in terms of hardware?
I mean, I think full Qtness. I think in this case we were really inspired by, for instance, the architecture of Alessandro Mendini, that is a kind of postmodern architect, and so we tried to look at different forms and how they go together, and finding a good balance, something that evokes this idea of air quality and air reading, and there's kind of this head that looks up, kind of in this sniffing mode. And then the colors also kind of this contrast. They're all kind of chosen in that regard to fit into the home environment. I think what it means. I mean, I can talk for myself as a designer. There are kind of basic principles that we try to put in the objects that we made, and those principles are the balance of colors and form. So it's an exploration every time that we build something to make something that fits the context in which it goes in. And of course, this project has a lot of functional problems that we try to improve. With our second iteration and second iteration projects.
Yeah, let's dig into that. So, like changes between this Iris project and your current air quality sensor, but also, the changes that you've gone through in the design of this one, moving from prototype to product. And since you've been running it since 2017, there's got to have been a ton of different tweaks in both the like hardware and the software side, the interface. I'm just so curious about all of that. But maybe starting with like the progression you just mentioned from Iris to this air quality sensor.
Yeah, so I mean, maybe the first thing I can share is like the software side. The software side we've gone through. This is the beginning of kind of visualizing air pollution around us. And so as you see, this is like a very more technical interface. And slowly we just like evolved. We kept exploring different ways to visualize and getting understanding patterns. This is there is a lot of exploration just on the software side. And I think the notable thing here is that we've been really thinking about what is important to know. And I think the product is the interface in some way. It's also the interface. It's kind of the immediate and is the pattern. And is the pattern recognition that we are very good as humans to do, but we need the tools to be able to do that. And so you see these are some of the evolution that turned eventually into this, that is a more serene interface, is simpler, but it still allows to go and dig, get a detailed information on if you want to see what was actually the number. We always show the AQI and then the kind of the raw values of ppm 10, 2.5, and 1.0. And we try to make this as kind of transparent and reliable as possible. So this is one part of this story of getting from zero to or from prototype to what is probably a shippable little interface. And I think if you want to see some prototypes, I'm super excited to share those as well.
Oh yes,
like
I would
some
love
hardware
to.
things.
Yeah.
So let me see if I can. Okay, I'm gonna switch to this camera, and let me show you some of these as well. So let's see. So this is the prototype as we have it right now, but kind of at the beginning we've been kind of as you would expect. The early prototypes were basically just just an Arduino with a sensor on, and there was a time in which we get a lot of different modules and we tested them, and then we decided that this module was one of the best ones. And actually, this module is also there is a Nature article that talks about air quality, and they do a survey of different kind of air quality modules, and this is one of the best ones. So I feel very good about this sensor to be pretty reliable, and that's also what came out from our observations. This is what we call the bomb, and this was kind of our the sensor that we brought with us, and it looks like a little bomb. And yeah, we connected this to. Just we brought it with us. We had it battery powered, and when we were going on holidays, we were like just curious. It's like, oh, can we? What's the quality here? And we just plug this in and read it on this little LCD screen. So this is kind of like the sensor that we used in 2017 and 2018, and as you see, the ARES project is basically an evolution of this project. It basically used more or less similar components. And then we start to brainstorm on what's the kind of evolution, the next evolution of that. And here we started to basically use this interface in a and getting very similar, like in a very similar form factor. Let's see here. Then this is probably the first prototype of very similar, but we change the scale, and as you can see, we have like debugging. Test points here, and then many different iterations, changing, testing different LEDs, and then to finally arrive to kind of the final kind of, or mostly final. So this is what we landed with at the end. So you get a kind of a historical overview of the project from the inception to where we are now.
This is so cool. And I noticed also on your website you have this previous an Arduino microcontroller called the Z1. And this is more of an Atmega 32 based one.
Yes.
As opposed to the current one is based on the ESP32. I'm really curious about your the difference of working on this project, or things that you learned from making your own microcontroller before, and how that progressed to this project. Because you can see lots of similarities between the two, obviously. And yeah.
Yeah, I think, well, so this project, so one thing that you need to know is that I'm also I'm also a teacher. So I've been teaching. Um, I mean, I've been teaching in different places. Most recently, I've been an instructor for the course called Designing Emerging Technologies at UC Berkeley in the Jacobs
Ooh.
Institute for Design and Innovation. And when I work with students, I feel like I've identified some things that we always need to do, and so I've decided I'm building microcontrollers to kind of get past the Arduino. Like, can we do an Arduino that does 1.5 per 1.5 of what is needed to do, right? It's like does Arduino plus something else. But this project specific, so that to give you a sense of, like, I've been building a lot of different microcontrollers, like meant for education, and specifically Z1 was more like a personal one. That's actually the one that I built as my own Arduino. What would I do if I put my own, like, what would be the best Arduino possible? And the best Arduino possible for me has an optocoupler built in, because that's a thing that I always need. And I always need to, like, put an optocoupler down and look at the pins and which one is the emitter, which one is, and so that's built in. And an optocoupler is something that is really, really cool. Basically, allows you to hack into anything. So if you have a remote control, you could just take the buttons apart, put two cables, solder them, and then you can basically trigger programmatically whatever you want from there.
Cool.
And that is on that screw terminal. There is a screw terminal also with an analog sensor, so you can just, like, go and connect an analog sensor. And then there are two ways of connecting the USB cable, so you can easily embed it into prototypes if you want a standard prototype, or a prototype that is a kind of more flat form factor. So those are a lot of kind of design consideration that are part of this project. And so basically, this is kind of a personal thing, but that's how this came to be. And then, of course, having some built-in outputs. So that's why we have this little LED panel. And we build a lot of things with this. We were thinking to make kind of bike lights or many different things, but this has been kind of a personal project. And the Arduino that I use also, I like male pins rather than female pins on the boards themselves. So that's why you see that what's soldered there are male headers.
And why do you prefer male headers? So personally, I use a lot of servos, so those usually have like a female header on it. But like, what are you doing with that?
I mean, I think I found it pretty easy to just, like, connect, sensors straight into them. I've been just using, like, jumpers that are like the jumpers are female versus the headers that are on the board. I found that to be more, like, stronger. I don't know. It's just a preference.
Legit.
Yeah.
I love this, like, dual USB thing. I have very rarely seen that. I can't think of any instances, in fact. And the fact that you've got, like, one that's horizontally mounted and one that's like, or one that's like sort of flush with the board and one that sticks out so that you can easily power it while it's like standing up and stuff. That is so cool.
So that's a very very utilitarian design.
We have a cool question in the comments, and I will get to that. Thank you, David, for submitting that. But while we're still on the subject, this is a teaching tool, the Z1, and this new one, the air quality sensor, is also designed to be hackable with custom Arduino code. How do you design an Arduino sketch, or do you make a library? How do you make it so that it's approachable for people? Obviously, there's the rule of them, like, commenting your code, but like, how else do you make it so that it's good for other people to approach?
Yeah, I think that's an excellent question. And we can talk more about other projects also that I've open sourced. And
Ooh,
I think
yeah.
that's really it's not simple, and probably I'm not even that good at it. I think I think open source. I try to package it as much as I can in a simple form and give pretty clear direction of people's like, these are the libraries, this is how you compile it the first time. I have a Linux computer, and so I try things on my computer that is a Mac and on this Linux computer to make sure that everything runs. And I try to have like clean installs. There is so many things that you need to that can go wrong or that are different. So I think apart from kind of try to give as much documentation as possible, at least how to go from there is a bunch of code and this code now can compile and go to the board. I think that's the most important part. I think packaging things in libraries is also something that I think is more on the inspired tinkering kind of mentality rather than like really dig into the code. So it's like, for instance, in this air quality code, I have a JavaScript kind of a utility library in which you can just take it and basically you don't need to dig into it. That library takes care of talking with the sensor, taking the data out of that, and then you can build potentially your own visualization completely in a completely different way. So that's something that I think is part of that conversation, and it doesn't require you to like, oh, I need to learn everything, how everything works, but you can say, like, oh, this part is taken care for me, and I can just build my user interface, for instance.
Very cool. Okay, now let's get to that question from David, and thank you for answering that, by the way. So he asks, what considerations went into the human interactions for this product, EKG? So I had this question as well. So I like being able to glance at my like ARRowNet from across the room and be like, oh, I should open a window. I noticed you have this beautiful touch interaction, and how did you decide on that? Obviously, it's like a personal thing about how it fits into your home and workflow, but yeah.
Yeah, I mean, the object is a very quiet object, and I think it doesn't do anything unless you invoke it. So if you touch it, it just shows you what's the current air quality level, and there is a pretty distinct signifier that tells you that that's where you need to touch. So and then when the air quality gets bad, there is kind of this glow that we saw before. There is this kind of red glow that shows where the air quality has gone overboard, and so you can have a sense of that too. In terms of human interactions, is a very simple object. So I think the mental model people can have is like, this is a quiet interface. If you want to invoke it, you just tap and you get the current air quality level. If something is wrong, you look at it and it's kind of catching your attention. If you have it in your kitchen or in your hallways, you when you pass by, this captures your attention, and you see that something is not right with your air quality. So those are, I think, those are the those are the considerations. We didn't want to have a light always on because I think it captures too much of your attention, and then almost when there is better quality, you almost don't notice it. So it's there when things are bad, and it tried to be kind of a loud device, but otherwise it's very quiet. And I think the other thing that maybe I can mention is there are two LDRs, there are two light sensors on the device that are reading the ambient light intensity, and those are used to basically tune the brightness of the LEDs. So at night it's not going to be this giant glare, but
nice.
yeah. So it's when there is brightness in the room, we are like as bright as we can be. But then in the in the evening, if it's like very dark, is also respect kind of your the brightness. So thank you, David, for the question.
Yeah, there's another aspect of this which I hadn't thought about, which is that like the again, I keep bringing up this Aeronet 4, but that's just because it's a sensor that I live with in my daily life. And it's got an e-paper sensor, which it only refreshes like once every couple of minutes. You can set it 1, 5, 10 minutes, which is very low power. And of course, having LEDs always on would consume a lot more. And with the sustainability aspect of your design studio, that makes a ton of sense. Also, this thing about like, yeah, we are super just attracted to lights, and it makes me think of like a concept of attention pollution. I'm sure someone else has already come up with this idea, but like, I don't want my smoke alarm to always be telling me things are fine, things are fine, things are fine, even if it's cute and pretty. Like, I would like it to just like stick out when there is something to look at. So that totally makes sense.
Yeah, I think you described it perfectly right.
I have so many questions for you, but I gotta pick one now. There's a really cool. Okay, so I would also love to delve into other work that you've done, like with the humane product, which hopefully we'll get a minute to talk about as well. But we've been part of this conversation online about sharing the data and possibly like contributing to a database that's public. I was wondering if you wanted to talk about that a little bit as like a possible future plan.
Yeah. I think, the product by itself, as we created, we didn't want to have our own service storing other people's data. And we think there is an incredible value in doing that, in potentially connecting the data of many, many more people, and, seeing that from a kind of neighborhood scale or city scale, or even as an aggregate of all the homes and seeing their air quality. I think there is a lot to learn there. And the sensor, in the way it is built, if someone wants to do that, people are super welcome to change the code, create a server. A university could say, oh, we are going to take these sensors and make them and make them and connect them to a centralized place in which we can get the data and use it for research, or use it for better policy making around home appliances, about whatever needs to be. So the idea of openness, I think, it speaks to that, to the opportunities and possibilities that a platform like this offers. So if people are interested in changing it and in connecting it in a kind of better globalized scale, in which pattern recognition can happen not just at an individual level, but more on a neighborhood, city, state, policy scale, I think that the opportunities are all there to be exploited.
Yeah. Okay. Let's dig into. Okay. Oh man, I want to ask you about Tramontana, which is not but it's another project that you've done of platform for interested spaces. I also want to ask you about your shop and this concept of like space tourism, which is a huge question right now. I want to give people a really quick just overview of some other interesting stuff that you've done, and maybe if you come back we could talk about some of this stuff as well as your work at Humane. Which of those things are you most interested in talking about right now? Actually, I'll let you pick.
I think why don't we start with the stickers?
Okay.
Just because that's a fun thing to talk about, and also probably, I don't know, a more mature thing. But then we can talk about Tramontana. I think is a very cool project.
Cool.
So, well, we have been, part of the principles for sustainable computing that we've been talking about are kind of this philosophical, more like kind of brainy work. And then at some point we were like, we just want to push something out that is kind of fun and that speak to these values. And so we came out with these 3 stickers that basically take the irony. And I think that our perspective is very skewed towards Silicon Valley, in which, we have a lot of conversation about, multiplanetary species. Everyone is very excited about space exploration. And instead, on our side, we've been kind of like, we are deeply Earthlings. We really love Earth. We really love the other creatures that are on our vessel, our spaceship Earth. And so we are kind of, as a provocation, we've been thinking, the fun space tourism. Let's also have another voice that talks about how instead we could just focus on making the things that we have on Earth better. And so I think the fun space tourism is kind of like, we don't want our public money to be spent into Virgin Galactic and SpaceX for reasons that are outside of public good, that benefit very few people. And if you actually dig into the finances of a lot of these companies, there is a lot of public funds, a lot of tax money that goes into financing these companies, that of course they have some benefits, but also there is a lot of just like big, a very, very few people having access to that. And even if you projected 50 years, 100 years in the future, still there are very, very few people that could potentially benefit of going in a space hotel and see the Earth from outside. But I think the majority of people, just from an energy perspective, the energy that it takes to send someone into space is enormous. And that energy can be used in many different ways. So that's kind of a little bit what we advocate. And I think as a, anyway, that's a little bit of the conversation that is much more ample, much more complex. And I think with the war in Ukraine, we are seeing how space technology has been kind of fundamental has been part of that conversation too. So it's a very complex issue, but we kind of want to be making stickers that have a lot of irony. So there is that about space tourism. There is a no to convenience culture that is also a topic that we talk about. We talk about convenience as the only engine that has been moving our like technological, industrial complex, but we should have other values that push technology. I mean, for us, especially for me, has been kind of beauty and community, and those are not antithetic to technology. It's just a different way in which you build technology. If you want to build technology that fosters community, if you want to build technology that is beautiful first, or anyway, that's a little bit of a very is an overarching theme of my work and the things that I've been thinking about. And then the last one is less meat, less hurricanes. That is also fun, and speaks about the fact that we became vegetarian and we kind of have been embracing a more sustainable lifestyle. And we live in this in a world in which we see the impacts of climate change, and that's another way of making it less.
I love a little house up here. These are so cute. Like, they have a great message, but they're also really cute. The defund space tourism one really speaks to me because I just came from this conference called Analog Astronaut, and I have my own thoughts about like flying to there for one thing, but also there's this huge, like, the distinction between tourism and science. And there tends to be a focus on the overview effect in this community, where it's like, by seeing the whole world and how we're all connected, it can change your worldview. But also that maybe we don't need to send we have billions and billions of humans, and even just the ones who are like decision makers, sending them all to space, like you mentioned, would take vast amounts of resources and kind of increase the problem. But at the same time, this conference is all about how like you're making analog missions before you go to space on Earth, and not only like testing stuff out, but the concept of having like a closed environment, a closed loop environment that has to be internally sustainable, like, and self-contained, is very deeply tied to obviously our concerns on sustaining planet Earth. And so there's such a rich amount of science and exploration that we can do in the space topic without necessarily it just, like you say, being kind of an ego trip, which I think is amazing.
Yeah.
So good. We've got just a couple of minutes left. I wonder if there's something else you'd like to throw in there. Someday we'll have to get you on to talk about more of your hardware projects and the humane stuff and everything. But any thoughts before we wrap up here?
I think maybe the closing, you asked me about Tramontana. I can talk about a little bit about that and how that ties to kind of teaching. Just to conclude on that. So Tramontana is a platform for creating interactive spaces. And this is a project that comes as a kind of reflection on the fact that we've been building personal computers, and it's really hard to make kind of more spatial computers, to make room size computers, I think. And that yields the ability to make kind of more communal experiences. And so based on that understanding, I built a platform that basically is a library for creative coding platforms like processing, like P5.js, open frameworks, and little apps. And also there is an hardware component. I think I made a few boards and I distributed in the universities where I've been teaching. I think that there should be a hardware component of it somewhere. Probably the last two boards. Yes, these Tramontana boards. And basically the idea is that you have a centralized place in which you write all the code and the logic, and then you extend all the other devices that have their own computation, but they become a set of inputs and outputs. And by doing that, you can create very complex interaction with many different touch points. And this has been one of the tools that I've been using with students, especially in the classes that are, I've been teaching designing emerging technologies most recently, and in the past I've been teaching interactive spaces, and a space that I'm really interested about. And this kind of ties, my work as a designer of interfaces, but also designer of things that live in space that are coherent in the context, and so that also speaks about the quality sensor. Kind of ties it all together, this idea of having a fluidity in which things in a fluidity of this computing environment where all the things live together.
Very cool. Thanks for telling us about that. Awesome. Let's go back through some of the things that we talked about really quick. I'm curious about the name of your studio, but like, yeah. Actually, yeah, can you tell us about that really quick?
Very quick. I mean, LUFF is a technical term, is a nautical term that is the kind of the front part of the sails, is the first part of the sail that enters the wind. And I'm a big fan of sailors, and I met you also at the sailing club sometimes. So it kind of has a reference to that. Tramontana is also a reference to wind, and that's kind of the environment that I love to spend time on. And so that there is a reference to that, but that's just like to give a little bit more branding to this project, not just like me. And potentially also, a lot of people have given hands to help me in many different parts. Some people have been helping me on writing. Some people have been helping me on checking my schematics and writing, looking at the code. So also to have an umbrella that, where a collective of people can feel part of. So actually a big thanks to all my friends and collaborators that have supported me and helped me to get from an idea to the Kickstarter now. I'm super excited for all the people that have supported me.
Yeah, and congratulations again. I got a note that if someone has a golden opportunity to donate $3 right now, obviously the goal is more about like, it'd be so cool just to see that go up to 6666. Awesome. Anyway, love that. I had totally forgotten that we ran into each other at the sailing place. That is so cool. Yeah. You can check out prdr.com. The Big Cartel shop, which I'll link in the description below. Would love to see you on Hackster. We've got the Instagram page, PRDR. We've got tramontana.xyz. And then also your GitHub, which I didn't actually end up pulling up at all, but I'm guessing that this might be where people would look for the Arduino stuff in the future about the airflow.
Yes. So we are, as soon as the project is being released, we are gonna, I need to clean the code and prepare it for being open source. The Tramontana code, we open source the Android app and the iOS app, and that has been, going back to your comment of what it takes to open source something, those have been a big effort in cleaning up that code and put it online.
Sweet. Thanks again for joining us, and thank you everyone who jumped in on the comments and everyone who joined us live. And if you're watching this after the fact, thank you as well. Be sure to follow us for more cool hardware stuff in your feed. We do unboxings, tutorials, interviews all the time. And yeah, happy Tuesday, and thanks again to Pierre for joining us. This has been awesome.
Thank you very much. See you next time.
Cheers.